What happens when a single flaw in the Linux kernel allows any local user to read your server's most sensitive files? And what happens when a popular download manager's official site is compromised, serving a Python rat disguised as a Linux installer? Today, we are looking at a week where Linux security took a hit from multiple angles. We have two critical kernel vulnerabilities, a supply chain attack that bypassed standard antivirus, and a new backdoor targeting SSH credentials. But perhaps the most interesting story this week isn't a vulnerability at all. It's about how the rise of AI is fundamentally changing and currently breaking the way security bugs are reported to the Linux kernel maintainers. If you run a Linux server, a home lab, or even just use Linux on the desktop, you need to understand how these vulnerabilities work, why they happened, and exactly what you need to do to protect your systems. We're going to break down the technical details of the ssh-keysign-pwn exploit, analyze the JDownloader compromise, and look at the new rules Linus Torvalds just implemented for AI bug reports. Let's start with the kernel. The first major issue we need to discuss is tracked as CVE 2026-46333. It's been nicknamed ssh-keysign-pwn, and it's a critical local privilege escalation vulnerability. Now, when we say local privilege escalation, it means an attacker already needs some level of access to the system. They can't just exploit this over the network without prior authentication. However, once they have that initial foothold, maybe through a compromised web application or a weak user password, this vulnerability allows them to completely bypass intended permission checks. The core of the issue lies in the Linux kernel's ptrace access control logic, specifically within the ptrace may access function. Trace is a system call used primarily for debugging. It allows one process to observe and control the execution of another process. It's incredibly powerful, which is why access to it is heavily restricted. But a logic flaw tied to the kernel's dumpability checks creates a very dangerous race condition. To understand how this race condition works, we need to look at what happens when a privileged process shuts down. Think of a helper program like ssh-keysign or change. When these programs exit, there is a very brief window where their memory context is cleared, meaning the memory pointer is set to null, but their open file descriptors still exist. During this tiny gap, an unprivileged local attacker can use a system call called pidfd-gtfd to steal those file descriptors. Because the memory context is already gone, the kernel fails to properly enforce access restrictions. That would normally block this action. The attacker essentially grabs a handle to a file that they shouldn't have access to right before the kernel cleans it up. A public proof of concept exploit is already available on GitHub. Demonstrates how an attacker can repeatedly spawn processes to race against a privileged helper's exit path. According to researchers, the exploit typically succeeds within 100 to 2,000 attempts. On a modern system, that takes almost no time at all. The consequences of this race condition are severe. By targeting SSH keysign, an attacker can read the SSH host private keys directly from the SSH configuration directory. By targeting charge, they can read the shadow password file, exposing all the password hashes on the system for offline cracking. Theft of SSH private keys is particularly dangerous. It allows attackers to impersonate systems, conduct man-in-the-middle attacks, and potentially move laterally across your infrastructure. If you reuse SSH keys across different environments, a single compromised server could lead to a much wider breach. This flaw affects most major Linux distributions running kernels before the patch is released around May 14th. This includes Ubuntu, Debian, Arch Linux, CentOS, Alma Linux, and Raspberry Pi OS. The underlying bug has reportedly existed for over 6 years, meaning many long-term, unpatched deployments are highly vulnerable. If you manage Linux systems, your immediate priority is to apply the latest kernel patches provided by your distribution. Do not wait on this. If you suspect a system might have been compromised, or if you just want to be absolutely safe, you should rotate all SSH keys on the affected systems. You should also audit your access logs for sensitive files like the shadow password database, and monitor for any suspicious use of ptrace or PIDFD related system calls. But ssh-keysign-pwn wasn't the only kernel vulnerability disclosed this week. We also saw the release of Fragnesia, tracked as CVE 2026-46300. This is another local privilege escalation vulnerability, and it's closely related to the Dirty Frag vulnerability we discussed previously. Fragnesia exploits a logic bug in the Linux XFRM ESP in TCP subsystem. It allows an unprivileged process to achieve arbitrary byte writes into the kernel page cache of read-only files. Just like the trace race condition, this requires an immediate kernel update to fix. While kernel vulnerabilities require local access, supply chain attacks can compromise your system the moment you install new software. This week, we saw a prime example with the popular download manager, JDownloader. Between May 6th and May 7th, the official JDownloader website was compromised due to an unpatched CMS bug. The attackers didn't need authentication, they modified the access control lists and swapped out the legitimate download links. Specifically, they replaced the Windows Alternative installer and the Linux shell installer with malicious versions. What makes this particularly concerning is that the main Java archive, macOS, Flatpak, Wingit, Snap, and in-app updates were completely unaffected. The update channels use RSA signed verification, which held strong. But if you went to the website and downloaded the Linux shell installer during that window, you were downloading a remote access Trojan. The payload delivered by the compromised JDownloader links was a Python-based rat loader heavily obfuscated using PAM-DOORa. On Linux systems, it dropped its payload into a hidden directory /root.local/share/.pkg. It then established persistence by modifying /etc/profile.d/systemd.sh, masquerading as a legitimate system service called /usr/libexec/upowerd. Several users reported that standard antivirus scans, including Microsoft Defender and Malwarebytes, came back completely clean post-infection. This is a stark reminder that signature-based antivirus alone is not enough to protect a Linux system against custom obfuscated malware. The legitimate JDownloader installers are signed by AppWork GmbH. The malicious ones showed publishers like Zipline LLC or the Water Team. Finally, we need to talk about AI and how it is causing chaos for the Linux kernel security team. The release of the Linux 7.1 RC4 kernel pre-patch this week included some unusual new documentation. It was not about a new feature or a hardware driver. It was specifically about how to responsibly report security bugs. Linus Torvalds and the kernel maintainers are pushing back hard against a massive influx of AI-generated bug reports. According to Torvalds, the continued flood of AI reports has made the security mailing list almost entirely unmanageable. Speaking of compromised credentials, researchers also detailed a new Linux backdoor this week named PamDOORa. PamDOORa specifically targets the Pluggable Authentication Module Framework, or PAM. PAM is the core system that handles user authentication on almost all Linux distributions. By injecting a malicious PAM module, attackers can intercept and steal SSH credentials in plain text as users log in. They can also use this module to maintain covert access to the system, completely bypassing normal authentication checks. To defend against threats like PAM-DOORa, you need to regularly monitor your /etc/pam.d/directory for unauthorized changes or unfamiliar modules. More importantly, this underscores why enforcing multi-factor authentication for SSH is no longer optional. MFA mitigates the impact of stolen passwords because the attacker still needs the second factor to log in. Finally, we need to talk about AI and how it's causing chaos for the Linux kernel security team. The release of the Linux 7.1 RC4 kernel pre-patch this week included some unusual new documentation. It wasn't about a new feature or a hardware driver. It was specifically about how to responsibly report security bugs. Linus Torvalds and the kernel maintainers are pushing back hard against a massive influx of AI-generated bug reports. According to Torvalds, the continued flood of AI reports has made the security mailing list almost entirely unmanageable. The problem isn't necessarily that the AI tools are finding fake bugs. The problem is massive duplication. Different people are using the same AI tools to scan the codebase, finding the exact same issues, and submitting them privately to the security list. Maintainers are spending all their time forwarding duplicate reports or explaining that an issue was already fixed publicly weeks ago. The new documentation makes it clear bugs detected by AI are, by definition, not secret. Treating them as 0 days on a private list is a waste of time for everyone involved. If an AI tool found it, another AI tool will find it too. The kernel team is now requiring that these types of reports be handled through public channels to reduce the pointless churn. This situation with the kernel mailing list is a perfect example of the growing pains we're experiencing with AI in cybersecurity. AI is a powerful tool for finding vulnerabilities, but without human verification and coordination, it just creates noise. We need to use these tools responsibly and respect the time of the open source maintainers who keep our infrastructure running. If you found this breakdown of the week's security news helpful, don't forget to like and subscribe for more deep dives into Linux security. And be sure to sign up for the weekly newsletter at tondoeslinux.com/subscribe to get these updates straight to your inbox. Stay secure.